Have you ever wondered about the magic behind a Lego brick? That perfect, satisfying click when two pieces connect. Why is it that a brick you get today will fit perfectly with one your parents played with 30 years ago? Imagine you're building a new creation. You have a box full of shiny new bricks and a handful of older, well-loved pieces. You pick up a red brick from 1990 and a blue one made just last week. You press them together, and they connect without any problem at all. They hold tight, just as they should. How is this incredible consistency possible across billions of bricks made over decades? The answer isn't magic. It's an amazing feat of science and engineering called precision manufacturing. Making every single brick almost identical is one of the biggest challenges in the world of production. It all begins with a digital design. Before any plastic is melted, every curve and stud of a Lego brick exists as a perfect computer model. This digital blueprint ensures that every new design will work with every brick that has ever come before it. Next is the material. Lego bricks are made from a special, strong plastic called ABS. This material is chosen because it's tough, holds its color, and has just the right amount of gloss. It arrives at the factory as millions of tiny plastic granules, looking a bit like colorful sand. These granules are fed into giant machines and heated to over 230 degrees Celsius. This intense heat melts the plastic into a thick, flowing liquid, the consistency of toothpaste. This molten plastic is the lifeblood of the entire process, ready to be shaped into something new. Now comes the most important part of the entire journey, the mold. These aren't simple plastic trays. Lego molds are incredibly complex, heavy blocks of steel, crafted with extreme accuracy. Some molds can cost hundreds of thousands of dollars to make because they have to be absolutely perfect. They are the heart of the factory, where simple liquid plastic is transformed into the bricks you know and love. The molten plastic is injected into the steel mold with enormous force. This pressure ensures the plastic fills every single corner and crevice inside the mold cavity. It's a process that happens in just a few seconds, creating multiple bricks at once. The machine applies a pressure of up to 150 tons, which is like having 25 elephants stand on the mold. Here's where the real secret lies. The precision of the mold is measured in micrometers. A micrometer is 1/1000th of a millimeter. For Lego, the allowed error or tolerance is just 2 micrometers. To give you an idea, a single human hair is about 70 micrometers thick. The engineering here is 35 times more precise than that. Once the mold is filled, it has to cool down instantly so the plastic hardens into a solid brick. Water is flushed through channels inside the mold, cooling the hot plastic in about 7 seconds. This rapid cooling is crucial for the brick to hold its exact shape and size without warping. With the bricks now solid, the mold opens, and small pins push the newly formed pieces out. They fall onto a conveyor belt, and the mold closes again, ready for the next injection of plastic. This cycle repeats thousands of times an hour. But the process isn't over yet. Not every brick that is made gets to go into a box. Quality control is constant. Every so often, batches of bricks are pulled from the line for testing. Both highly trained technicians and ultra-precise robots measure the bricks to make sure they meet the strict standards. They check the height, the length, and the clutch power, the force needed to connect and separate them. If a brick is even a tiny fraction of a micrometer off, the entire batch it came from is rejected and recycled. So that perfect click you hear isn't just the sound of plastic, it's the sound of incredible precision, relentless quality, and brilliant engineering. It's a guarantee from the engineers that your imagination will never be limited by a piece that doesn't fit. It teaches us that even in the most playful objects, we can find some of the world's most serious and inspiring engineering.